Alright, so in this video we're going to take our mesh that we just made and set up the boundary conditions and such, and we'll run the numerical solution. Before we go to the solution, we want to check the mesh. We'll click on mesh and go down to check, make sure we don't have any errors or other warnings. We don't, which is good. We'll also take a look at the mesh size, so we'll click on report, mesh size, click update, and we'll see at 63,000 cells, which is reasonable. Close that and click on switch to solution. It'll ask us that we check the mesh, which we did, so we'll switch to solution, yes. Okay, so now we're working on the setup. We'll go under models, and for viscous, we will take the K omega model is right for the, but we'll switch this to gecko and hit OK. Close that out. Next, for materials, check under fluid air. We want to check to make sure we have the right properties for air at standard temperature and pressure, which we do, so that's okay. We'll close that. Go under cell zone conditions, fluid, check under the flow domain. And for this one, we need to remember this is a rotating flow domain. So we're going to select frame motion and set our rotation origin to be at 0. And we'll rotate around the positive z-axis, so 0, 0, 1. And we'll put in a rotational velocity of 98 radians per second. And click OK. Then we'll look under boundary conditions for the inlets. We'll see the velocity inlet, or for the inlet and the inlet top. And for both of these, we'll go into double click on inlet. Well, for velocity, we'll put in components, and the only velocity that's non-zero is z, which is 6 meters per second. That's all we need to do there. And we'll do the same thing for inlet top. Components, and 6 in the z direction. We can look at our other ones. Internal flow domain, we don't need to worry about that. For the outlet, we'll check on our outlet and make sure that looks all right. We'll see the gauge pressure at the outlet is 0. And then finally, we'll look at periodic. We have our periodic boundary condition and our wall on the blade wall. So that's all good.